Hello everybody. In this video we're going to be taking a look at discount, tax, tip related problems. They all kind of fall within the same kind of universe of math problems here. So we'll look at two different variations. Let's focus on number one first. If you want to try these on your own, you could pause it, do both of them, and then watch the answers. However you want to do this is pretty much up to you. So number one says, a jacket that is $85 is now 25% off. How much does this jacket now cost? So we're assuming it was $85 like on the shelf. There's like a 25% off coupon. So how much is it going to cost after that sale is applied? Okay, so all of these, why I mentioned earlier, why are these all in the same kind of math topic or the same math universe? They're all related to proportions. So there's really no difference in how we kind of think about these. They're all using the same basic setup here. So we're going to set up a proportion. We're going to think in terms of the percent here. So 100% would be paying full price. Okay, that would be the $85. That's 100%. It's a full 100% of the price. We want to figure out what it's going to be when it's 25% off. Now, when something's 25% off, you're actually paying for 75% of it. Obviously, you're just doing the subtraction there to get the 75. That's called an adjusted percent. And ultimately, we want to figure out how much is that 75%? How much are we paying? We're paying 75%, great, but how much is that actually in dollars? We could use the 25. If we did use 25 in the numerator there, that would be telling us our savings. So then we would have one added step of just subtracting it. If we got, let's say, savings of $15, we would have to subtract and then say, oh, okay, we're paying $70. So adjusting it now is going to save us that last step. And now, as with any proportion, we can solve by cross multiplying. So I'm going to get 100x equals an 85 times 75. Let's always do things like we don't have a calculator, unfortunately for me. So that's going to be 42. 35, that's 56, or 59 with the added 3. So we're going to get 5, 7, 3, 63.75. Okay. Always good practice to kind of know how to do stuff without a calculator. That day one or book one where we don't have one, you're responsible for doing the basic multiplication algorithms like this, with or without decimals. Now, dividing by 100 is very easy. We're just simply going to move that decimal place, which is right now after the 5, 2 spaces to the left, and it's going to be 63.75. A good way to check with these is kind of check that it, obviously check your math work, check that it makes sense. Let's say we got an answer of like $92. Obviously, we know we messed up somewhere. It's 25% off. It kind of makes sense. It fits our answer without even looking at the numbers closely. It's less than 85. Things like that. Okay, so that was a discount problem. And like I said, all of these are using the same proportion setup, adjusting things, so they're all related. Doesn't really change when we, there's very slight changes, I should say, when we alternate between tax or tip or discount. Okay, we'll look at number 2 here. Joe and Alex eat lunch together at Applebee's. The total comes to $42, and they decide to leave an 8% tip. How much of a tip do they leave? So how much are they actually tipping? How much is the waiter or waitress getting here? So same thing. I'm going to start with my proportion. You can always fill in the 100 right away. Okay, in this case, we're told we want it to be 8%. Why am I not adjusting it here? Why am I not saying 108? This is a tip we'd want to add if we were adjusting. The 108 would represent how much they're paying in total. We just literally want to find out how much of a tip they're leaving. Okay, so you do have to kind of read into the context of the problem of whether or not you should adjust. We would never want to do this problem and put a 92 in there. Okay, that would represent a discount problem. It would either be 108 or 8. Tax and tip, we're adding to 100 to adjust. Tax and tip are costing us additional things, unfortunately. The 42 would represent the full or original price, whatever we want to call it here. And we're finding 8% of 42. Okay, so we could do that with an equation setup. We could do it with a proportion like this here. We're going to cross multiply. We're going to get 100x equals 42 times 8 is going to be 336, I believe. Let me just check. Yep. Okay, and once again, dividing by 100, just move the decimal place over 2 times, we get $3.36 as a tip. And just in case you're curious, we can find the total. How would we do that? Like, how much are they paying in total? We'd simply just add. And that would be the same as if we did 108 in our adjusted percent. And it would be 45.36. So I'm adding to the 42. That's how much they're paying in total out of their pocket for the lunch. Okay? So these were discount, tax, and tip related problems, all involving an adjusted percent or sometimes just using the percent and a proportion setup. Best way to kind of work your way through these problems, start with the 100 in the bottom right hand corner and know whether your variable should be in the numerator or denominator on the left hand side, whether it's an original, which we'll also take a look at some of those problems, or the quote-unquote piece or part of the problem. Okay, thank you guys for watching, and hopefully you found this helpful.